Hi everyone, welcome back. The purpose of this lab is to illustrate the various parts of a wave and to understand the interference patterns. We'll return to this in a little bit after we go over some background and basic terminology. Let's go over some basic background. A wavelength is the distance of one wave, which is best represented by the distance between two consecutive crests, which are the highest point of the wavelength, or the distance between two troughs, which are the lowest points of a wavelength. In addition, the amplitude of a wave is the displacement of a wave from its equilibrium point. Let's go a little farther. Wave velocity is the velocity at which waves crest or moves. A wave crest travels a distance of one wavelength, represented by lambda, in one period. Therefore, velocity is equal to displacement over time, which is equal to lambda over period, and frequency is equal to 1 over period. Therefore, wave velocity is equal to wavelength times frequency. The velocity of a wave depends on the medium through which it's traveling. The velocity of a wave of a stretch of a string is related to the tension force in the string and the mass per unit length of the string. Therefore, velocity is equal to the square root of the force of tension on the string divided by mu, which is the mass per unit length. Alright, so there are different types of waves. The motion of a particle in a wave can either be perpendicular to the wave direction, which are called transverse waves. That is represented by the second diagram. Or parallel to the wave direction, which are called longitudinal, which is represented by the diagram up top. An example of two students creating longitudinal and transverse waves can be seen next. You can try this in class as groups. Let's move on to interference. The superposition principle says that when two waves pass through the same point, the displacement is the arithmetic sum of the individual displacements. In the figure below, A exhibits destructive interference and B exhibits constructive interference. These figures show the sum of two waves. In A, they add constructively. In B, they add destructively. And in C, they add partially destructively. For further questions, please visit www.njctl.org. Thank you for your participation in this online lab. I'll see you next time.